What's the first level D's show up? 3. You just have to remember scandium starts the 3 Ds. Mine seem to be a little bit out of numerical order, so I shoved the 4S in between 3P and 3D. But we'll try and come back later today and explain why the 4S shows up there. 3D1. Some of them get to be pretty long. If I were asking for the full electron configuration of iodine, would that be a fairly long configuration? Do we have any options that are shorter than the full electron configuration?
Yes.
There's something I tend to call the abbreviated electron configuration. And these terms are sort of key, because when I give you a quiz or a test, I'm going to say you can give me the full electron configuration for these atoms, or give me the abbreviated. The abbreviated means we're going to put what we're going to call all the core electrons. We're going to represent them by just putting the preceding noble gas in brackets, and then putting only what are called the valence electrons. The core electrons for scandium would be the electrons that are present in the noble gas before scandium. I'm just defining a couple of terms here, because I haven't really used core electrons and valence electrons before. The core electrons for scandium would be the 18 electrons that are also present in argon, that part of the electron configuration. So I can call these core electrons. We'll see later on that when we undergo a chemical change, not much happens to the core electrons. But when we undergo a chemical change, the real change to the atom is occurring in the valence electrons, the ones that come in after the noble gas, just before it. So these are going to be my valence electrons here. What I'm going to do, if I was doing this, I'd write argon in brackets. That would represent all 18 core electrons. Then I just have to say, okay, I find argon, that's number 18. If I was reading off the periodic table, I just start writing with the 19th electron, which corresponds to potassium, calcium, and scandium. Potassium, 4th period, so it's filling up the 4s2. One more electron for scandium, 3d1. That would be the abbreviated as opposed to the full. Particularly for elements down towards the bottom of the periodic table, you're going to hope that you get asked for an abbreviated electron configuration, not a full electron configuration. What noble gas is just before iodine? Krypton. Kr, way over here on the side. Atomic number 36 here. There's going to be still a whole bunch of electrons beyond that, but I'd say this, the first 36 electrons. In brackets. And then we look again for what shows up after krypton. And work our way towards iodine. Rubidium. What level would rubidium start out? 5s, so that's 5s2. How about yttrium? Obviously that's what Y stands for, right? Ds, since it's the second batch of Ds, those would be 4 Ds. First batch of Ds is 3 Ds. These are 4 Ds, 5 Ds, 6 Ds down here. comes after the 4Ds? 5Ps. In this case, the way we're reading it, we're going through the fifth period. So the fifth period is the 5 S's, the 4Ds, and the 5Ps. How many blocks across will I have to go to get to iodine, including iodine? 5. So 5P5. Pretty easy to do. Most people get this down pretty easily. Do we need to do many other examples of abbreviated? Maybe give you one to work on your own?
Yes, please. Let's do the last. Forward electron configuration. What's that? The last one.
Maybe lead? Any idea what's going to trip up 25 to 40% of you on the quiz or test?
The F orbitals.
The F orbitals? Anybody forget the F orbitals?
I did.
Once you get down to the 6th and 7th period, you gotta start worrying about F orbitals. So just before lead is xenon. Xenon, atomic number 54. So if I go ahead and count up, next number should be atomic number 55. That's cesium. 6s2. So far, so good. And, okay, everybody likes to do their periodic tables a little differently. Let me see. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. Yep, they screwed this one up. Just skipping over to this one. It's not really a matter of screwing it up. Hopefully I'll get a chance to explain what's going on. You notice over here they got lanthanum, actinium, over here in the D block. Over there I was counting across and it's 15 elements because they included lanthanum and actinium in front of the lanthanide, sorry, in front of the 4F and the 5F elements. Usually lanthanum is considered to be 5D1, the first of the 5Ds. And then the rest of these would be the rest of the 5Ds. But the odd thing is, if you notice numerically, obviously 72 is the next number right after 57. When I count, I do 56, 57, 72. That's how everyone else counts. Obviously 57 should go to 58. That's one tip off here that you've got to include these elements, which are 14 across. The reason the number 14 matters so much is 4Fs, aren't there 7 different 4F orbitals? Shouldn't it take 14 electrons to fill them up? That's why I was double checking to see how many elements were in their series over there. 15 doesn't make sense unless you realize the first of the 15 isn't really a 4F, it's actually gonna be a 5D element. So this periodic table, the one you get on a test anyway, is a little bit more correct in terms of where they write things down. So again, 6 S's here. These are gonna be the 5Ds, and we're gonna fill them all the way up to get to lead. So I'll write the 5Ds down. And then in the middle of those 5Ds, they had the 4Fs. How many elements were in the 4Fs? 14. So we'll take 14 to fill that up. And so that brings me up to mercury. Then I have 1, 2 more elements to go past mercury. So I'm going to have 6p2. So again, I'm putting the arrow there on the 4F because that's something people tend to forget. 4Fs or 5Fs down towards the bottom of the periodic table. And again, you get partial credit. It's not like you get a 0 on that whole question for forgetting the 4Fs. But it's best to remember them. We'll come back later on and talk about what order is really the best order to list these in. But for right now, we'll just write them in the order that we read them off the periodic table. So we're technically talking about chapter 7 right now. But it's going to turn out that chapter 8 could easily have been included in chapter 7. It's just a continuation of discussion of electron configuration. That's what's going on in 8. To me, it makes sense to just talk about the electron configurations of ions. At the same time, we're talking about the electron configuration of neutral atoms. So technically, the electron configuration of ions, that's in chapter 8, I'm saying. But I'm going to talk about it now. Oxygen be 1s2, 2s2, 2p4, does that sound right? For just a neutral electron configuration. I'm just going to try and zip through and do full neutral electron configurations, and we'll talk about the ions that they like to form. So nitrogen 1s2, 2s2, 2p5. Am I doing that right? Okay. That's the problem, I've got these reversed. I better go drink some more coffee.
I would never do something immature like that. I would never want to write out.
So these are just a series of the periodic tables, I'm just increasing by 1, the last place each time. 1s2, 2s2, 2p6. Now I've filled up the 2p level. In fact, I filled up completely the n equals 2 level. The n equals 2 was the 2s and the 2p. So now I've got to jump up to sodium, and I'm going to start using the n equals 3 level. 1s2, 2s2, 2p6, 3s1. Am I just adding 1 electron to the last place each time? That's partly why I'm able to go through this so quick. I'm not really even thinking about it. I just changed the last one